record. Hey everyone, we're about to start our officially the first lecture. This is my first semester teaching CSCI, and having fucking Visual Studios fail on the Hello World has got to be one of the more embarrassing things that can happen. In fact, I was posting about it on Facebook. That was embarrassing. But as soon as I cleared out all the memory, like I flushed like a third of my memory, deleted a bunch of programs, it ran just fine. So let's start from Visual Studios. We'll start with creating a new project. We did this once last week or on Monday, but let's do it a few more times. Remember, you're going to create a new project. If it doesn't say empty project in C++ console, whether you're doing it on Windows or Mac or something else, well, you may not be doing it on anything but Windows, since I don't know if Visual Studios works well on the others. We're going to say next, empty project. First thing I'm going to do is make sure that it's going to where I want it to. The desktop, the folder I made for CSCI Labs, that's exactly where I want it to go to. And I'll just call it project 1. Fuck it. We're just studying for now. So I'll create the project. What is this properties window? I don't need that. Okay. Let's see where I want to move the zoom window down. Let's put it down there. That's out of the way. So the first thing we can do, we got to add a source file. We need source code. We're going to say right click on source file and say add new item. You know, if you want to leave it marked as source CPP, you can. I think you're better off at least giving me your name. And if you think you have a common last name, give me your first name too. I'll put project 1 in front, since that was what this one was called. And we will add. And it gives us a nice little empty field to work with. I'm going to test something real quick, see if I can write directly on this screen very well. Let's see. Can you see my handwriting?
Yes.
Awesome. This will make it easy to do some stuff where I don't need to do a bunch of stuff, like write it out very much. So I'll have write on screen capability. Let's turn off the annotate for now. And let's just go grab one of the programs we were looking at. Let's see. We'll go to our courses. You know what? Oh, wait, I was already in the course. Let's go home. Let's grab that. Let's grab that code that didn't run earlier. Nope, our first program. There we go. And we'll just copy and paste it. This will be a brief recap on that one. And okay, so this is the code. I am missing something. I'm missing a line. I didn't copy it over. I like Visual Studios. It tells me comments in green. And when I see my name not in green, I know something's wrong. That's pretty handy. So I'm going to run it real quick and just show that it works. And be pissed if it doesn't, because it worked last Monday night after I deleted everything. It can take a little bit. It pops up a new window where it has executed the program. Good God, why are you running this slow? It is not that hard of a problem. Where'd it go? Wow, that was, what the fuck? You know what? I'm moving a better computer. I'm moving my gaming computer in here. Right now I'm on a Surface Pro. I'm going to use the Surface Pro on the side as a screen to write on, and I'm using my gaming computer starting next week because this is a little ridiculous. So it runs, it generates its own window to run it, and it'll say press any key to close this window. Why are the diagnostic tools popped up? I didn't ask for that. Let's go look at where it landed, where everything was made. I had told it make it in the CSCI lab on my desktop, and it was called Project One. Project One, the solution is a Visual Studios thing. That's not what we want. That's not what we want, folks. So our source code, the CPP file, should be in this folder right here. And there it is, Project One, Jones, David. So that's our source code. We can see it if we right click it. This is what you'll submit. We'll walk through submitting it again later. If you want to look at it in a text editor, it's got all the same good stuff. This is actually, sometimes if you want, you need to edit a code that you wanted to submit, like, oh, I forgot to put my name at the top. It's almost easier to edit in Notepad real quick than it is to open up Visual Studios. But it's there. We should also have, is it here? It's in the debug folder. Where is the fucking executable? It's supposed to be here. Let me go back up to the top. Let's check there. Project One application. So I can click it and it runs it, but it shuts it down right away. The problem with the program is that the way it is, it shuts it down really quickly. But let's walk through what we've got again. We've got the hashtag include. That is a preprocessor directive. We're going to use that to include libraries for different things. When you downloaded Visual Studios and installed it, it installed all these libraries for you. They give all that cool commands for this stuff in there. Any of these things that you include, you need to put between those triangle brackets. Okay. IO stream is the name of the library, the input output stream. And when we're doing an output goes to the screen. It uses the insertion operator. And that's what this double less than sign is. A single less than sign. Notice what happens when I have a single less than sign. Well, first off, the code tells me something's wrong with the red underline. But when I try to run it, what happens? There were build errors. When you get something like this, where the code doesn't even want to compile, what you have there is called a syntax error. So syntax error is a language error. You know what? I can actually type that into here. So if the code doesn't compile due to bad programming language or typos, this is called a syntax error. It is one of the more common ones. Syntax error. And if I put because right now what the less than sign is a mathematical operation that we know from math. The double less than sign is in the insertion operator. So they mean two different things, even in a row. Notice that spacing doesn't matter. Oh shit, it does. Does it work? Spacing doesn't matter anywhere else. Does it fuck it up here? It does. That's one of the few spots spacing does matter. Okay. I could have things on the same line. Let me get rid of that bit right there. So I can have everything on the same line. As long as there is a semicolon, the computer reads it as an end line. So this should compile just fine. I know it didn't do that in the W3 schools thing that we had the other day, the online one, but it does just fine here. In fact, you could have your entire program as one line. Oftentimes, if you right click on like a website, you'll see all the code, the Java or JavaScript code that they use. It's all just one continuous sequence of shit. Hard to read. That's useful on their end because it's harder to steal. You have to take some more work taking it apart. But it's not really readable. So we want to do stuff that's more readable for our users or other programmers at work. Oftentimes when you're working on stuff, you're going to be working as a team, not just as an individual. And so you want your stuff to be able to be read easy. The cout and the insertion operator are both operations in the IO stream. That's why we included it, so that it would recognize these commands. So is endline. Those are always good. A handy thing for you to throw in is, I don't think this works on Mac, but system pause like this. If you got system and then pause in quotation marks in parentheses and then the semicolon, I'm going to compile it and run it. And now remember, it doesn't have it. The last time I ran it, it had a bunch of text underneath it when it ended it. This press any key to continue is the system pause key. It's a great way for debugging shit. I'm going to use that a lot. So it's really handy. I'll comment that out for now. And I want to note something that happened. I commented out, but I haven't ran it again. I haven't compiled it again. So my code hasn't changed. Let's see what's going on in chat. See and ignore should work, but we haven't gotten there yet. We're getting there. Okay. This was the one I just compiled, 425, it's 426. Even though I commented out system pause, I haven't recompiled it, so this still has a system pause in it. And when I was running it earlier, it was turning off. Now when I run it, it doesn't turn off. So if you're gonna make a program for grandma or your younger brother or your friends or some shit like that, or you're working on apps and you don't want it to go away right away and it doesn't like ask for any input from them, a system pause at the end makes it really easy to at least make sure it stays on the screen. This will go away only after I hit something. So I could have a wall of text there to read if I wanted to write a goddamn book and just print it out to the screen like that. You could read it that way. So there's that. Any questions so far? Adrian, don't be afraid to talk. Oh, wait, you're at the campus, so that might be why you're not
Is
talking.
that you said it's good for debugging? Is that just like so you can kind of see where each line of code operates and make sure that each section functions before it goes to the next?
Yep. And I've done stuff. We'll do it. Well, I will deliberately generate errors at times to create errors and go, how are we going to do this? But having it in there, another thing that helps, if you've got a lot of code, every time you have it in there, I can do a cout, first pause here, or pause one.
So the actual code itself won't go, or it won't tell you that there's something wrong until the pause is skipped. Is that correct?
Well, yeah, if there's an error after the pause, we'll go over integers next week, but I'm just gonna use it here real quick. The pause just stops the program. If it compiled, if the language all worked, it pauses it. If there's an error in the program and it's not, you know, it runs, but it's crashing or does something crazy, we'll do that in a second on one of the labs we have set up. It will give you a means of going, you could put this in a bunch of places. Notice I put in pause X here. I'm going to say here, I'll say X equals X plus 1. We're going to go over this more next week. And I will copy and paste this. I do this a lot when I'm debugging my own program. So, and we can read what's going on with what we see on the screen at the same time. Let's see if I can resize this. So we've got the hello world. We've got the sup folks, gamers rock. It says pause one. The X is the one right there. God, I wanted a space in there. And then it's got to the system pause and it stopped. And if I hit it again, now it goes to the next line and says x equals the old x, which was 1. X equals x plus 1 is now x now equals 2. So it reassigns x to a new value. We will definitely cover this integer stuff a lot more next week. But now when it does the next line, x is now 2. It says pause 2. It's got another pause there. And if I hit enter, I will give you an example of why this doesn't work or why we would want that in there. What if I didn't say x equals x plus 1? What if I said x equals x divided by 0? X equals, what's dividing by 0? What does that do?
Implodes the universe.
It implodes the universe. Yeah. Dividing by increasingly smaller numbers like 0.000001 will give you things like in the billions. And the closer you get to 0, the closer it goes to infinity. Dividing by 0 is basically infinity. And computers don't like that. So what happens when I run it? It's definitely an error, right? We know we can't do that. What happens when we do that? I've got the system pause in, and it's got a pause there, but when I do the next one, why is it not going? It's trying to do x equals x divided by 0. Notice it's not doing shit.
Oh, so more or less it's just like pinpoints.
Yeah.
Okay,
You can
gotcha.
use it to track where you did stuff wrong. So
Okay.
come up here to click continue, and it'll finish eventually stopping the program. You might have to click close on the window. I did. But it gives you a way of pausing it. I could say here, instead of x equals x divided by 0, I'm going to say C out x divided by 0. And we'll come across the same problem. The pause is there, but it doesn't like it. In fact, what is it doing? It's telling me there's an exception. Something's wrong. Okay. In fact, in the screen, it's actually showing me the line. It's got a nice little arrow. That's, I think, I don't know that 2019 did that. 2022 has this in here. It shows up pretty nice. It will also show up down here. Where is it? Let me close the Solution Explorer. It's got a lot of weird shit open at the bottom. Breakpoints, exceptions, not settings, output, the output window, exception thrown, but it doesn't really say as much where. There might be something else. There's supposed to be an error tab. It's not showing. I'll have to look for it in a second. But there was a problem there. And if I don't have system pause in there, let's take a look at what happens there. Let me close this. I'll say continue so it ends. Before I do, let me copy all this because I don't want to delete anything that I've written, but I'm going to comment it all out real quick. A quick comment out thing is this thing right up here, comment out the selected lines. And I will add a little bit more to the comment out. This generated a pause break before the error. So if we place these strategically, we can help narrow down where our error is. I'm going to do the same thing up here. I'm going to get rid of the system pause though. Let's just comment it out. Now, if I try to run it, there's no system pause before the divided by 0. Let's see what happens. Nothing. Can't do nothing. And I can see over here, there's an error. But if I give this code to grandma or my wife, I'm going to use my wife. My grandmother passed away. My wife is not tech savvy at all. Like she'll have me do Google searches. I'm like, what the fuck? Google searches aren't hard. But like people struggle putting the right thing into a Google search, and my wife is one of them. She'll think she did something wrong here. What did, if I gave this to my wife and this happened, is that her fault that she can't get it to run? No, it's my fault. I coded it up. In fact, it's always the programmer's fault. We'll see in a second another problem that has that. So here we had the system pause taken out. The program doesn't work. I'm surprised it didn't crash, to be honest. I've seen it crash, like 2019, I think it crashed. So up here, when we did it before, we had a syntax error. Where did that go? Oh, up here, if the code doesn't compile due to a bad language. This isn't a bad, is it a bad language thing? No, the language works fine. You can say divide by 0. I can say 5 divided by 0 all the time. It works, I can, anything I can say in different languages. But if I actually try to do the calculation, that's where the problem happens. So this can be, let's put it right here. Dividing by 0 and other such failures in reasoning or logic are called logic errors. Okay. This category.
Would that not be considered a runtime error?
That's where I was going. This category, logic errors happens when you run it. So they are called runtime errors also. Runtime errors is the more general one. Here, the reason why it didn't run was a logic error. It's dividing by 0. That's one of the questionable ones. Sometimes the logic error is if you've got, when we go into looping and stuff like that, if you got your looping set up wrong and you try to access something that doesn't exist, you had some bad logic and stuff.
So like if you were reaching for a resource that didn't exist or something like that.
Yes.
Okay.
Exactly. Like if I said go grab the 5th book on the shelf and there's only 4, you're gonna get there and be like, what the fuck, Jones? I don't know what you're doing. So if you're like a robot or a computer, you'll just sit there and keep waiting for book 5 to show up, and that's what it was doing. People can reason out this isn't working. So all these errors are my fault. Or the programmer's fault. Whoever it may be. So that's some good stuff there. Is there any questions on this one?
Negatory.
All right. Let's see. I'm going to comment out that divided by 0 real quick. Run it so it's compiled that way so it doesn't make me angry. Bam, done. And I'm going to close this project and open up a new one. Let's see what else we want to look at. Let's take a look at one of the modules. Our module coming up. Lab 1A. Ooh, quiz 1B is going to be available soon. You can see it right now, even though it's grayed out because I'm on teacher screen. But I'm going to set it to active tonight. It's based off the reading material and it has questions related to like the errors that we just talked about. The quizzes aren't worth a lot of your grade, so don't be like too concerned if you miss something. Just use it as it's more of a learning tool. But definitely try to read up on some of the stuff we did, like in the intro and see out section up here. There is reading assignments and stuff like that. The visual history one's kind of fun. We'll take a look at that in a little bit. Let's take a look at Lab 1B, the guessing game. Let's see what it says to do. Did I put the syllabus quiz after the? Let me go back. God, I do not want it after the labs. They need to be before it.
The other question I had, since
Yeah.
we're on this page, most of the other classes that I've been working with, whatever this interface is called again, Canvas. There's a assignments tab.
It's down here. It's grayed out so students don't have it. Is that something you find useful? I can activate it.
Yeah, I mean, I like to be able to kind of like after I've done the reading and stuff like that, to be able to, you know, just jump right into the assignments rather than having to go to like modules and then click next or find the right module with all the other stuff in there. But
let me see if I can do that, because it might have like a lot of some of these I'm not going to use, but also it's got like the midterm. When I come down here, old midterms, old quizzes and stuff, and you might be able to access it ahead of time. There's no student view here. Oh, maybe that's because students are. Let me look at it this weekend, and I'll let me make a note of it. Check on assignment tabs. Make assignments viewable. Okay. All right.
Thanks.
So let's take a look at. Go back to modules. And we're going to look at Lab 1B. Lab 1B says copy and paste the guess number game into the IDE, compile and run the game. Did anyone try this?
yeah,
Okay, let's do that together. I'll do it right now. This is Lab 1B. So let me see. What else does it say? Call it Lab 1B dash my name. So that's what I'm going to do. I'll create a new project. I'm going to say next. We'll go do this kind of quick. Lab 1B, me. Don't be cute and say me, because everyone's a me. And we will make a new source file. Lab 1B, me, C++ file, C PP. And let's see, let me come over here and grab it. It says play the game several times, induce a runtime error. In other words, try to break the game. And then it says read the code and try to follow it. And then turn it in. Since we're not really doing anything to change the program, I could pretty much turn it in as soon as I compile this. Let's take a look at it. We've got 3 includes. Apparently there's 3 libraries we're including. The IO stream, CTime. CTime is something that allows us to use random stuff based off time. And we'll cover that later. C standard library is useful and for a lot of stuff. We'll also do more with that later. I'm just going to do what it says, run it and try to play the game. Without reading the code, let's just see what it does. All right, I have a number between 1 and 1,000. Can you guess my number? Oh, I'm a math guy. I'm going to just keep cutting the shit in half and try to play it smart. 500 is too low, which means it's between 501 and 1,000. Let's go 750. That's too low. Oh, it's higher. Let's go 875. That's halfway between 750 and 1,000. Again, too low. Let's go 925. That's not quite half, but it's close enough. 965. Wow. 980. 975. 970. 969. 68. I'm not being strategic anymore. All right, so I got to do it a bunch of times. It looks like probably this game would probably be more fun if we like tracked how many times I guessed. But that's for another day, another dollar, another dime.
Does it count as breaking the game if you just put in a different character?
What do you mean by a different character?
Press yes and then press H and enter.
Oh, can I stop it? Is it, I can't push any numbers? That constitutes a break. So David wanted to put that, it was you, right, David?
Yeah.
David said, let's type in an H when we run it. So again, that's not David screwing it up. That's me giving him a program that isn't good. This isn't good. I did H. In fact, typing any letter should technically break it. It generates a runtime error in the fact that the game or the program can't continue as intended. So it's definitely a runtime error. That's a great way to break the game. There are lots of things as we go through this that will break the program. And doing stuff like error trapping or finding where the error is, we will go into much later in the semester, how to pinpoint errors and stuff like that. I didn't restrict an answer on what could be input, right?
If we were to turn this in the lab B, would we turn in what was wrong, or how exactly would we turn in just the code itself? Or
actually, let's turn it in. Let's do what it says. So, well, I did what it said. I read the code. I haven't read the code yet. I'll do that in a second. But we did try to break it, and we found a way to break it. I might, just to show that I did do it, I might come in here and say right at the top, oh, I am missing something. David Jones. The date is January 12th. I could spell. My cursor's in the way. 12th, 2022. Back. Do that. And then I'm going to say lab 1B guessing game. That was part of the instructions. And then I could add what broke it here. Since it didn't actually specify, let me just pick where to put it. I broke it by typing a letter rather than a number.
So I broke it by changing the dividing by 0, same thing. I just took the random generation, instead of as a percent of 1,000, I did it as a percent of 0.
Oh, you changed the code.
Yeah.
This is not. We'll cover that. And this is called the modulus operator. We will cover that a little bit later. It's doing a division by 0, but probably not in the way that you're thinking. But I could see that. You could say I edited the code and did that. That's fine. The point was to play around with it a little bit. I'll run it, make sure that everything's compiled away. Like I probably could have just clicked save and not run it.
oh, so when turning in the assignments, you just explain how you broke it at the top.
Well, like on this one, other things it will tell you specifically what to do. Like this first week, they're pretty easy.
Oh, okay.
So when I do it, I'll go in here and student view. I got to be in student view. I can click start assignment. And since I deliberately chose where I placed it, I put it on my desktop. I made it easy to find. This was lab 1B me, and I want the CPP file, which is in the first folder. There it is right there. So I'll say open, and then I'd click submit. And that's all you need to do. That's kind of how you, and rather than having me, you'll have your name. Having said that, watch what happens if I try to make a change real quick, because you will do this. I am sure you will. Someone in here will do this and may have already done it. What happens if I decide to rename this here? Oh shit. I didn't do rename. I just said open. Double click too quick. If I change my name here, I can still submit this fine. This should submit just fine. If I try to run this again though, there's build errors. What's the build error? There is no lab1b-me CPP file. So, you will, that'll cause you grief later on. Let me change it back. Let's see if changing it back helps. I don't even know if changing it back can help. Sometimes it's better off just to copy and paste your whole code into a new program that's named appropriately. I changed the name back. It's got capital M, lowercase e. Let's see if it runs correctly now. Hopefully it does. So you can change it back and fix it. But if you don't know what you had it originally named or something like that, sometimes it's just easier to copy and paste the whole code into something new. Make a new project. So if you have that problem in the future, keep that in mind. Sometimes it's better. Don't retype it, just copy and paste. So we did try to break it. We looked at some errors going on. We can try to look at it real quick. The main is where all the action happens. Notice the main only has a couple things. It's got this thing right here that says srand time 0. That time thing might be related to that, and it is. We'll talk about that later. Guess game has got parentheses. Guess game is listed down here as a parentheses. This will be chapter 3, I think, or section module 3 or 4. When we do something like this, this is called a function. And this one didn't have any input, so we can just run it like that. And there's some couts. We knew what the couts did. You see this right here? What's going on here? I got a whole bunch of lines. The only semicolon is right here. I only have one end line right here, right? Let's take a look at that. Let's run that and take a look at that side by side. I've only got one end line right here at the end, which is why the cursor is coming down here. But why do I have returns right here and right here? So as we'll show more later, this /n with a forward, oops, I did forward slash there. You got the backward, oh, fuck, I don't know which one's called the backward slash or forward slash. You got these slashes for comment. You do the other slash that goes the other way. /n means put a new line here. You'll also find other ones that are useful. /t is put a tab here. So I'll put that, I'll show you that right here real quick, /t. And then I'll close it and rerun it. But notice I got this over several lines. That's what I was trying to say with, and I could put a bunch of spaces here. I could put spaces after this. I could put spaces after this. And when I run it, it doesn't care about all those spaces. The only space it's really showing is right here. And that's from the /t or inserting a tab. So that's kind of some neat stuff. That spacing thing can be really helpful, especially when you're typing a line that's way too long. But you don't really want to break it up into different things. So you can type it all as one cout and then do this enter thing and make it show up over different lines like this. We had the double less than when we did the couts before, and that put stuff in the input or the output stream. That put stuff to the screen. But when we did please type your first guess, the first thing we did was we entered a number. Well, that's where this in comes in. That's something else that goes with in. So when you're doing, trying to input stuff, and we'll cover this more next week as well when we're doing other stuff, we use C in rather than C out. We're inputting and the sign flips. These are insertion operators. These right here, this is called the extraction operator. That's my dog. It doesn't sound like a dog, but it is. This is an extraction operator. What we're doing is we're extracting the next thing that goes into the input-output stream. We're going to extract that value and use it in our code. That's what it's doing right there. It looks like we got some other functions. This is correct thing. We'll cover that more. But that's pretty much an intro to what's going on. I want you guys to try to play around with it, look at it. Tinker with it, maybe try to, if you want, see what changing the words and stuff is. You'll find this while response equals y with this do thing. It's called a do while loop, is really handy because when I ran the program, God damn it, dog, Astro. When I run the program, let's see, let me get it through real quick. Uh, 275. Oh, too low, which means it's higher, 285. 288. All right, rather than having to rerun the entire program again, what it says is, would you like to play again? It's waiting for another input. It's going to input whatever I type into response. So I can do while response equals y. Look at that. That's a lowercase y. So if I type in y and I hit enter, it's going to run the program again. In fact, if I hit YY, it should run again as well. It's just pulling the first letter. If I use capital Y, it didn't run again. We'll do looping like this later on, about halfway through the semester. The looping stuff is kind of fun. So that's what your objectives are for this week. Let's see, let me stop sharing real quick. David had to go to his other class. Let's talk about some history of programming real quick. In fact, I did want to mention something else real quick. In fact, let's go look for it. If you're working and trying to do this on a Mac, I've heard that a program, I had Ellipse in that thing. I've also heard Xcode works. So maybe narrow it down, Xcode, C++. There you go. So if you got a Mac, this is a good program for you. It'll prompt you on how to install it and do all that stuff as well and how to use it. So that's for Mac users if you don't have, if you're not using Visual Studios. Let's take a look at, oh, let's get rid of leave student view. Let's talk about some history for programming for a little bit. In fact, let's look at something else real quick. We had it, where was it? Intro and C out, I think it was. The visual history of programming languages. This is kind of neat. It's got a bunch of language. See all those dots? Those are all computer languages, all of them. C's right here. C++ is right here. C++, we can click on it. We can see what other languages it's influencing. C#, Perl, PHP, stuff like that. And it's influenced by C. Let's close that one out and zoom back out. C is influenced by a shit like assembly language, Fortran, Algol. These are old languages. I think the difference between C++ and C# C++ is free open source code, free code. And then C#, I think Microsoft started developing shit for their stuff, and they wanted to redefine the language, add stuff to it. And the computer board, the international board for people that decide what goes in and what stays out, they said, you're trying to take it away from being free. You got to call a new language. So they called it C#. There's a lot of languages here. Let's see what else. Let's unclick C. Let's see if I can Pascal. Oh, Pascal, look at that. That's got to be old. Pascal is only influenced by Al and Algol. So there's a large history of programming. One of the first things that was done is, his name was Charles Babbage. It sounds like cabbage. This is what he looks like. To me, this motherfucker looks like Liam Neeson to me, like an old Liam Neeson. I don't know if it's just me, but let's take a look at it. Let's learn a little bit something about him. He was it says English polymath. I'm kind of curious what a polymath is. A polymath is an individual whose knowledge spans a substantial number of subjects, known to draw on complex bodies of knowledge to solve specific problems. So he uses a lot of math to solve shit. He's a mathematician, a philosopher, mechanical engineer, and he originated the concept of a digital programmable computer. He had something called the difference engine. Look at that bad boy, super huge. Designed in early 1800s. It's been over 200 years since he started doing this stuff. That's how long ago they started doing this stuff. That's crazy, right? Did we even have electricity back then? When did we start using electricity? Not until after that. So we didn't even really use electricity until after that. Let's go back and look at our other guy here, Charles Babbage. So he came up with these ideas, and so they were doing stuff with like steam and stuff like that, and using it to do that. But he's kind of like the great grandfather of computing. And it really started with a horrendous looking machine like that. Well, they call him father of the computer, but maybe we could go with grandfather at this point. And then some other people came along. You might have heard of Alan Turing. Alan Turing, the movie, the Enigma game or something like that. Is that what it's called? Nope. Let's just go with Turing and Enigma. The Imitation Game. The Imitation Game was about Alan Turing. Let's go back and look at him. He is attributed to be the father of theoretical computer science and artificial intelligence. He made the Turing machine, which can be considered a model of a general purpose computer. He was inspired a lot by a lady named Ada Lovelace, son of Lord Byron. Ada Lovelace, back in at the same time as Charles Babbage. So Ada Lovelace, she lived, oh wow, from 1815 to 1852. She died when she was 36. Fuck, I'm already older than that. And she did more in her life than I'm ever going to do. Ada Lovelace said, okay, she looked at that difference engine machine and said, you know what, I think we could do more than just do add or subtract shit like that. She thought the machines could carry out more complex algorithms, which is effectively, she becomes our first computer programmer. And that's her, the Countess of Lovelace, Ada Lovelace. She was an English mathematician and writer. I'm sure she was a writer because Lord Byron is a renowned pirate, her father. So she came up with, decided, you know what, we could make programs where the computer does a sequence of operations, a bunch of operations to come up with a solution. And then Alan Turing came along and kind of came up with the idea of how to make that work with making a general computer. So he's an ancestor of that. Then we bring in Grace Hopper. Grace Hopper comes along. She's in the 1900s. She's an American computer scientist. She was a Navy Rear Admiral. And she is, she took some, was the first to devise the theory of machine-independent programming languages. She later went on to create COBOL, one of the earliest high-level programming languages. That's apparently still in use today by some people. I don't know who. Maybe it's the roots of C and stuff like that. But she figured this out way back then. Prior to joining the Navy. Wow, she joined the Navy after earning a PhD in Yale. So she was a professor of math. Jesus, look at this chick. She tried to enlist in the Navy for World War II, but was ejected when she was 34. I wonder if she must have gone in. Oh, she joined the Navy Reserves. So she didn't go in the war, but she joined the military because, like, let's stop the Nazis kind of thing. And contrary to what you might see in some of the news, Nazi and fascism is bad. There's my 2 pieces on that. But she's attributed to coming up with one of the first high-level programming languages. That's what C++ is. High-level programming language is something that we use, like we take common words and stuff like that, or words we make up, but are words, and they represent a bunch of operations. Like that C out that we used earlier, that is a word. It's not a word we use anywhere else but in programming, but it does tell the computer to go and take whatever is here and take it and put it character for character somewhere else on the screen, and things like that. So that's what the higher level programming languages are. But computers don't use those words. They don't understand what cout is. They understand ones and zeros, on and off. You will hear other teachers say that computer science is not magic. Fuck, it isn't. If you can explain to me with any good reason why I can send electricity through a piece of metal and I can play Fortnite or Elder Scrolls Online or Dark Souls, and why I can calculate astrophysics by just sending electricity through a piece of metal, and you don't tell me that's magic, that's some bullshit. Just because it works doesn't mean it isn't magic. I think that's just magic. I don't know how to explain it, so it's magic to me. But she said, okay, she found out how to make these language. She made a language that language is a recipe basically for what the computer will do in the binary code, zeros and ones and zeros, which is the lower level, the machine level. So she did that. Another lady that's famous, and oh my, Hedy Lamarr is a looker. She's a beauty. Actress, Austrian-born American film actress and inventor. Guess what she did? Other than making a bunch of movies and stuff, she worked on Bluetooth and GPS technology. And let's see. Did she do it when she was with the Navy? At the beginning of World War II, she and composer developed a radio guidance systems for Allied torpedoes. She did it for the Navy. And they didn't adopt her stuff till later on, but she's like the mother of Bluetooth. So what does this all have in common? What do these people all have in common? Well, first off, ooh, I was about to write on my screen with a pen. That would have been bad. Most of these people were mathematicians. And that is why many of the steps and operations that we do in programming follows like an algorithm approach that mathematicians use. Like when you do algebra, you guys have been in calculus. When you do Newton's method, I don't know if you've learned Newton's method yet. You might be doing that in calc too. Newton's method, stuff like that. They're very algorithmic. Do this, do this, do this, then restart, do it again, restart, do it again. So a lot of repeats or recursion. A lot of that comes from mathematicians. That's where why a lot of it's that way. But another thing to note is a lot are women. People say that I don't know why they teach young women and girls that math and science is for boys. That's some bullshit. Some of our best computer scientists ever have been women. Some of our best scientists ever have been women. Some of our leading, super smart people, many of them, I'm betting half, maybe less than half, just because they weren't given the access they should have, are women. Women are just as good as us. In fact, for a long time, computers used to be people who computed or people who did these calculations before they had computers. So, let me turn that off real quick. If you want to see a good film that's related to that, Hidden Figures is about something like that. It's about the women that worked at NASA before they used a computer. They put a man on the moon using a slide rule, right? They did some calculations that were, pretty basic back then. Well, for me, slide rule isn't basic, but they did a lot of stuff by hand. So computers used to be people, and it was predominantly women. Women are quite capable, quite smart. And unfortunately, nowadays, there's not enough women in the field. If you talk to Google and any of the big companies, Apple and stuff like that, there are a lot of women that work for them, but it's not half like it should be. They are all constantly looking for more women to like meet a quota kind of thing. So if you're in this class and you're a woman and you want to go all the way, you got it probably easier than a guy in the same spot, just because you're desired, you're wanted there. Sorry guys, that's a bad beat, but that's how that is. Let's see, did I miss anybody I wanted to share? We talked about Babbage, Lovelace, Turing, Hopper. We got Hedy Lamarr. Von Neumann did something. I forget what he did. John von Neumann. He was a mathematician. When you get into differential equations, there's some shit that von Neumann did. He has something in computing also. Computer science, what did he do? He wrote stuff on computing, so he helped advance the stuff too. A lot of mathematicians in the field that led to it.
Out of curiosity, what did Newman do in diffs?
What? What do you do in diffs? Or what did he do in diffs? What did he do in diffs? Okay, let's take a look. It's been a while since I taught diffs, so let me look. It might be partial differential equations. It might not be in differential equations. Yep, that's definitely partial. He's also known for Fourier. He worked with Fourier on it. Oh, the boundary conditions. So when you have boundary conditions, the von Neumann conditions, I believe, are the zeros. There's Dirichlet. He also did boundary conditions, von Neumann boundary conditions. They were for specific types of physics problems and different boundary conditions. One of them did like wavelengths through a pipe or a solid cylinder, and you have one condition at one end, one condition at the other, usually different. And what's the gradient of it along the pipe? You also have like in a rectangle or something where there's heat, the heat stuff, where it's cold on one side and hot on the other, the propagation of heat, the diffusion of heat. So there's a lot of boundary condition problems. Cauchy, Dirichlet. I love this name, Dirichlet. It doesn't sound like Dirichlet. It looks like Dirichlet. It looks like
Yeah,
Dirichlet.
we actually started talking about that in
Dirichlet.
our physics class too, I think.
What?
Interesting. I said, oh yeah, we just started talking about the boundary conditions on for our physics class.
Oh yeah.
For
A
physics
lot of the
57.
differential equations are in physics.
Right,
If you go into engineering and take the E&M electromagnetics or start going in circuits, you see a lot of it there. There's differential equations there that have because it's the differential equations often relate stuff over time or space and time. They allow you to see what happens in any given area over time. And so since stuff is changing over time, you have derivatives and you're often trying to work back to and find stuff. So that's where it comes up. ODEs, PDEs. Oh, did Dirichlet do the Laplace operator? No. Neumann conditions were, yeah, boundary conditions. If you're having different boundary conditions at the ends of the pipes. This is waves, I think. I think that's the wave one. Thermodynamics, heat flux. So yeah, it'll come up in all the physics classes. You will see a lot of the names transfer over there. And that's kind of it. We kind of walked through doing the stuff. We looked at the introduction to this. We did some C out. We explored some error codes and stuff like that. What generates errors? We had syntax errors, which are language problems or bad coding. We had runtime errors, which occur when you try to run it. Something bad happens. And then we have logic errors where your algorithm is wrong or your math is wrong. You might have, you're trying to access elements of an array or a vector that are not available. We'll cover arrays later on. And then we looked at some of the history of computing. And that's it. Has anyone had a problem getting an IDE installed? Because other than that, the lecture's over unless you guys have questions or want to talk about anything else. That's what I have ready for you tonight. I want to make sure everyone's getting in the flow. Monday we have off. Monday is a holiday. By then I should have my nice gaming computer in here. I'm going to actually film not just using Zoom, but I'm going to do something called Camtasia where I can do some video editing. I'm going to try to start working on video editing and making cool YouTube videos. But that's for in the future. Don't forget to do the introduce yourself. It's due tonight. Please do it. It's in the modules. That's it. If no one's got any questions, I'm going to hit stop recording and we'll call it a wrap early and let you guys go do something more fun. Well, let's be honest. Is there anything more fun than programming?
Is all the homework is going to be in the modules? Just everything?
Everything's going to be in the modules, yeah.
Okay. Okay, cool. Thank you.
I'm just building what we're going to do over the semester. I have all the old problems used in former classes, but I'm going to pull out my Truxy textbook and come up with some new ones. And then ones I like too. All right, I'll call it a wrap. Stop recording.